Hey everyone, thanks for having me here. Uh, from wherever you are in the world, it's pretty late here in India, so uh, I mean, let's get to business. So basically, I've been working in the evaluation framework. Abby talked about. So we already know what is evaluation, how does it work, what can you do about it, like from end to end. There was one specific aspect that she touched upon is LLM as a judge, right? So just to be sure here, it is the second best thing that we have right now. If you have human evaluating your answers, or your responses or whatever, right? So you should definitely use those in the first place, because LLMs are stochastic. They can hallucinate, they can give they just give a probability. That's about it. So here I'll touch upon one aspect of evaluation, that is your custom in-house evaluators. So basically, why you shouldn't be using GPT-4 or like proprietary LLMs as a judge. Uh, what things you should do while evaluating your LLMs, how you can evaluate them in house, and what are the things. So yeah, let's get to the point. Yeah. So let me just find stuff. I hope it's in preview.
Okay.
Just let me know if it's in preview, right?
It's in preview.
Yeah. I'm not sure how to. Yeah. So basically, I've been working in this hallucination detection and evaluation for the past 2 years, dedicatedly working into it. Uh, and there are a lot of pitfalls. One thing for sure is that you really can't trust one LLM to evaluate the second LLM specifically for hallucination detection, and that in like open domain without track, if you don't have a context of what they are saying. So I just built this 5-page slide so that I could talk about the one specific thing is like in-house models. So first, why do you need in-house models? Okay, let's say you are a company, you have proprietary things, you have some evaluation criteria, and mind me, right? These evaluation criterias are not regarding the very traditional like matrices, like like hallucination, relevancy, context, these things. But let's say your company like post about funny things, right? So what you want your LLM to be, apart from being it like toxic free and whatever, you want it to be funny, right? How do you evaluate if a model is funny or not? So either you have humans evaluating your LLMs, but what about the runtime, right? When you have an LLM generating answer, how would you evaluate? The second best is LLM as a judge thing. So you need to have some specific criteria, right? That what is funny, what is not, and this is the base for LLM as a judge. You need to have specific criteria in terms of numbers, that okay, hey, this joke is funny, if it's like very funny, give it a score of 5. If not, then give it a score of 1, right? These kind of things that you need to make the model understand, and this is why the in-house models and everything comes in, because they are faster, right? They are cheaper. If you have some protected data, you don't want to the bigger organizations to see. So that's why you should move everything in house. Obviously you need to have some training data to train these models on, but trust me, if you have enough cleaner data, you would be able to get a way better model that beats GPT-4 or like whatever LMs you've been using by a huge margin. So that is the base of my talk. So you know uh, you are evaluating your stuff, but how do you really evaluate, right? What do you call an evaluation? So there are two basically different type of evaluations. One is that you just let's say there is a LLM, you fine tuned your llama 3.1, and you came up with like an amazing model. But how do you make sure that this model is like correct, it's accurate, right? So you have different like open source tools and everything that you can evaluate on. But what about your specific requirements that you need, that okay, is this answer sympathetic, is this answer funny, uh, or something else, right? So what you do is you create a data set, and that data set is like called the gold data set, that you compare your LLMs again. So what you do is you create a gold data set. It is like the most amazing, scored 5 in every aspect, and then you, once you have created your model, you just let it do it in like a relative manner. So your question will come, you will generate the answer, and you already know the perfect answer, right? So one thing is for sure, that LLM as a judge works best when you give it a context. Context means the uh, rubrics, the documentation, when to give score 1, when to give score 5, very detailed version of it, and then something to compare against, that you can do it in like the relative manner. So you compare two answers, you say, hey, which one is better, then you find out how many answers are better in which area. So this is how you do one kind of relative. Other is, if you don't have a like a relative data, what you can do is you can generate 2 to 3 answers. You can just rank them in based on their scores. That is like pseudo relative. And third is like the absolute one, that you can do is to just generate all the answers, get their scores, and take like what's the median score. If it qualifies, that you take it, otherwise you just discard it. Similar, but when it goes to production, right, you just have only two things. Either you can if you have time, if your generation is offline or in batch, you can generate multiple. So there is something semantic similarity and evaluations, that you generate multiple versions of an answer, and then you try to find these things are also used in hallucination detection and conformal prediction. That's another topic. But for this one, you just evaluate your uh, LLMs on the absolute scoring. So your question comes in, you evaluate it, and then you just do it. I mean, there are a lot of open source models that are second best too. So one thing common between them is this Judge LM. It's relative in nature. Prometheus, it's a suite of models, metrics. They provide relative, absolute, pseudo relative, and absolute scoring. So they provide is a fudge is also a model which is like faster version of these. So this is you can find them like open source, you can directly use them. So one thing is great about them is they are all very good at adapting your task. So you can take let's say a Prometheus, and just run it on your task. You just have to say, hey, this is my rubric, this is my documentation, this is my relative answer. And even if the model hasn't seen it in training, it will try to so it's more of a judge than an LLM. So coming to how do you actually design and deploy like a LM evaluator, right? So the main thing, the most important thing is the data that you have, that you need and you want to evaluate on. You can't use like just any data, any metric. You need to first define what metric do you have. Okay, so first convert your metrics into numbers. That funny is a score from 1 to 5. Try to keep it in like in a very constrained range, like 1 to 5 is usually what people do. Then like just get the best quality of data that you can have for the training. Because otherwise, if you are training on like any data, garbage in garbage out, that is like very cliche. But in this sense, your model will be biased, your evaluator will be biased towards one particular goal, one particular score, or one particular type. So if you have let's say a song creation model, right? So you can't be just working with hip hop or R&B or like rock music. So you need to have like a good amount of everything, and then you try to evaluate, right? So the proper scoring rules and everything should be there, right? Then second thing that I would advise when you are developing your own LLMs, until unless it's necessary to give a reasoning, right? So most of the LLMs, they try to give reasoning of why this answer is good or bad or whatever. So until unless it's very necessary, you shouldn't be using the reasoning, because what you can do is you can use those LLMs as a classifier, and that is the best use case of these LLMs as an evaluator. Because when you try to because the training criteria is very different, because it's in when you generate something, it's all the words cumulative loss that you are optimizing for. But in a classification manner or regression manner, it's the one single goal, that hey, how far is this score from my score, that is there. Secondly, if you can you leverage, it's a scoring based thing, right? So instead of cross entropy, you can just try to leverage something like EMD loss, earth mover distance, which was used in Western distance. uh, that is a very good indicator of score based implementation. Then your whatever LM you try to create as a evaluator, right? So just be mindful that you can't just really fine tune like 70B model and then deploy it, because it will be very slow, and some things have like time critical foundation. So what you can do is you can take a smaller model like 5.3 or other models, use them first. If they don't work, then go to bigger models. So what I've seen in my experiments is smaller models work as good as like large models, except the reasoning and the hallucination detection task, because they have limited capacity. That is different task. Then all the for deploying them, you need to have the proper setup. Means the LLM ops, the kind of attention you are using, the kind of tool you are using to deploy, whether it's quantized version or other thing. And coming to the last part, it's a self promotion thing, I would say. So there is a model that you can check out, is like fudge, that I came up with. It's currently state of the art in four benchmarks. So what happens is human evaluation is costly. You can't send your private data to GPT. Prometheus is like like it's an ensemble of models. It's a mixture of models, so it's very big. So what you can do is you can use 5.3, change the change it from like generative model to a classification or regression model. Use a different low strategy, and then yeah, there you go. A smaller model beating 10 times the larger models with just the change of criteria. So yeah, that's about it. I hope I was able to deliver something good.